Next topic is the hydraulic jumps. What is the meaning of hydraulic jump? The definition is the four depth chains which vary rapidly over a short length of the channel without any change in the channel configuration. This continuity is in the free surface elevation. Okay, you can see from this is surface on another surface. So that is this continuous between two surfaces, between before the jump and after the jump. This near the continuity we call the hydraulic jumps. Okay, we use the short HJ. Okay. The other case is absolute case. Is an obstruction in the channel. This is an absolute case. Downstream of the case is the supercritical flow. So you can see that downstream of the case with number is greater than 1, so it is subcritical flow. Okay, and downstream ends of the of the ridge flow is a upstream is a supercritical flow. But in this case, in downstream, is a subcritical flow. Okay, after the jump, the flow is subcritical flow. And the jump provides the mechanism to make the transition between two types of flow from the supercritical flow to subcritical flow. Okay. To analyze the equation for hydraulic jump, we cannot apply the energy equation because of the turbulent flow. There is a head loss in this behavior phenomena, so we can't use the energy equation. We have to apply the momentum equation for control volume. Okay, so assume that these two sections and draw the control volume and find the momentum at the point 1 and point 2, the short distance. So that is the momentum, the summation of force equal to rho v1 y1 times b and difference of velocity. So how to get this equation, I can show you how to derive from the original summation of force equal to the change of momentum, and we substitute m mass divided by t by rho q, and substitute q and area in this equation. So we got the summation of force equal to rho v1 y1 b and delta v in the left hand side equation. Next, we substitute the F in this equation for hydrostatic force, okay, and divided by rho Q. So we got the first equation. And next, we apply the continuity equation. V2 is a function of V1, it depends on the depth, okay. And from this is from the energy equation, we have the head loss in the for the energy equation from the turbulent flow. Okay. Next, we substitute the V2 from equation 2 in equation 1. So we got this equation. We can say that this is equation 2, equation 4. We can say that this is equation 4. So next, we rearrange this equation to find equation 5 here. Okay, how to rearrange from equation 4 to equation 5, and that is show you how to get this. The first, we substitute and find the equation of foot number and substitute y1 in this v1 square in this equation. Okay, v1 square and some g cancel, and so we got this equation and v square v1 square subtract v2 square equal to is a function of the foot number. And next, we rearrange to get the to keep foot number on the right hand side, everything for y on the left hand side. Okay, and this is cancelled for both term. Okay, come up. Finally, we got this equation 5. Okay, from equation 5 is look like the parabolic function ax squared bxc. So we can solve this equation to get this ratio of y2 v2. Okay, and negative solution is impossible, so we neglect negative solution, and we got the final the ratio of the depth y2 after the jump and 2y1 is before the jump. This is equation for hydraulic jump. Okay. Okay. And from equation 3 we can find the equation of head loss, that is head loss equation for the jump. Okay. They say that is the head loss is negative if foot number is less than 1. So hydraulic jump does not occur. So from this we can plot the curve like this. Once the foot number greater than 1, so we expect that the head loss over y1 increase, and y2 over y1 is increase. y2 over y1 is the ratio between after the jump depth and before jump depth.